In this module, we're going to add a sensor to a robot called a photoresistor, which senses the amount of ambient light that is available to the resistor. And we're going to be using it to implement a simple I'm upside down or I'm flipped over sensor to our robot with the assumption that it is darker on top of the robot when it is upside down. So for this module, I am assuming that you have a completed quick start. I'm also assuming you have a 10 kilo ohm resistor handy. 10 kilo ohm resistor is pretty good for indoor lighting. The amount of resistance of the resistor in this one we'll have to change it a little bit based on how much ambient light there is. So if your sensor ends up saturated, you'll want to grab a different one. And of course a photoresistor, which looks like this. It has a little squiggle under the window, and it behaves as a variable resistor based on lighting condition. And you're going to need some jumper wires too. So let's grab a couple of those, put them next to our circuit right there. So this one should be pretty quick. We're going to do the same thing we always do. We're going to go to the Johnny 5 documentation for photoresistor. We're going to look at our circuit, and then we're going to copy that circuit. So we're going to go ahead and find a spot on our board for this. I will, oh, and we're building something called a voltage divider. If you notice, these two are kind of in a little, like they're next to each other. They share a common pin around the sense. So you have ground going on one side of the photoresistor, which then goes to a pin that goes to the sense pin, which is one of the analog inputs. And then you have a voltage on the other side of the regular fixed resistor. And this is called a voltage divider, which allows us to sense the ratio of resistance between the photoresistor and the fixed resistor. So go ahead and do that. So I'm going to set up the photoresistor there. I'm going to take the fixed resistor. This looks like 10 kilo ohm. And I'm going to plug it into the same channel. Copy it to a couple down. Then to the side of the photoresistor, I'm going to hook it up to ground. So I'll use a green wire for that. Just going to use this other ground pin on the Arduino. And then I'm going to hook 5 volts voltage source from over here to the regular fixed resistor. And that looks reasonably visible there. I'm going to get that a little closer so you can see the circuit. But we actually want to be able to sense things that are happening. So we're going to take the middle pin between the fixed and photoresistor, and we're going to wire that up to one of the analog inputs. In this case, the example specifies analog input 2. So we'll go ahead and use that because we're not using that input yet. So plug that in there, and then just wire this one up to the pin that is halfway between the other two. Only some of the wires are overlapping. Great. So with the circuit done, we're just going to copy the code into our existing quick start source code. So here's the quick start, the source code at the end of the quick start. We're going to scroll on down, and we're going to create a photoresistor on analog 2. And there's a couple of things here. In addition to the pin, we also have a frequency. So the frequency is how often we're going to check the photoresistor to see how much light there is, and then call the callback when there's a sample. So if you make this too fast, you're going to get way too many samples. If you make it too slow, your robot's going to be slow to respond to that change in light. So we can add it to the REPL if we want to, although I wouldn't call it pot because that usually means potentiometer. So we'll call it the full-on name, just like a Java programmer would, photoresistor. And then we're going to add a callback. So this callback function will get called whenever, like every single sampling interval, or if your robot's running, if the thread's fully loaded, it'll call it as often as it can. So first what I'm going to do is I'm just going to run it with this stat value. I just want to log out what is happening. This will tell me if the sensor's been saturated. It'll also tell me what dark and light correspond to on the analog input. So let's go ahead and just run our program. node photoresistor.js. It's looking for the board, so I'm going to plug it in. And then every quarter second it's going to show me, it's going to tell me how bright it is. So we see that like 300-400 corresponds to the ambient light in this room. And if I cover it up entirely, it jumps up to like 700 or so. So what you're looking for is a threshold that you can use to determine whatever state. So if you wanted to know like when a laser's hitting it, it might go to a very low value. If you want to know when it's upside down, when it's been covered in darkness, if I take my whole circuit, boop, and flip it upside down, we know that like 700 or 800 corresponds to upside-down-ness. Whereas here, like from regular moving around, it doesn't seem like normal operation gets it above 600 very often. So if upside down is always above 700, we'll make 700 our threshold. So go back into here, and if this dot value is greater than 700, I'm upside down. Let's go ahead and run our program again. And what this could do is it could like operate a servo to flip our robot back over or something like that. So we'll go ahead and run it. Everything initializes. And now whenever we flip upside down, it complains that it's upside down. We could add a softer latch or something so that it only says it's upside down once. You write code. That's what we do. We like writing code. So that's about it. That is it. Hooking up an analog sensor like a photoresistor is as simple as that. So that is the end of this module. So happy hacking.